So we're going to demonstrate an APS Opcenter model designed for glassware, whether it be bottles or drinkware or something like that. So to a little bit of background, first of all, we have 3 furnaces that feed 6 molding and finishing lines. We have some constraints as regard to how much a furnace can pull, or how much molten glass you can pull from a furnace, and that's calculated by the weight of the gob, the speed of the gob. As it leaves there, you can calculate a furnace pull. Each furnace has a maximum weight of glass that it can provide. So we'll show you some plots. There's 60 units, so just for demonstration purposes, we're using units. So furnace A can draw as much as 60 from furnace A, 70 from furnace B, and 75 from furnace C. We'll demonstrate some use of changeover times. And in this particular model, we're using a feature called unlike. So if the next job that we're scheduling based on color, for example, if we're going from crystal clear to a green glass, that is an unlike change. So we'll insert 8 hours of setup time. So we're allowing the Opcenter APS model to determine how much setup time needs to be between jobs based on the attributes of those jobs. Then when we actually run the schedule, we have a sequence that we have to follow. So we need glass color to be the same as much as possible, because that, glass color is that big changeover. We want to minimize that. Then we want to keep the shapes the same as much as possible, keep the family groups the same as much as possible. And then finally, we have another constraint that colored glass can only run on one line. So you can't have the green colored glass being pulled from 2 different furnaces, for example. So that's the constraints that we're going to build into our model, and I'll demonstrate that next. Okay, so here's our APS Opcenter model. A little bit of real estate to describe. Here are our 6 lines. Here's all the jobs that we have to schedule. You notice these jobs have a part number, a due date, a quantity, then the glass temperature, the glass color, the shape, and then behind the scenes is the product family. Here is the furnace issues, the furnace constraint, which furnace we're going to be on, and then how we will calculate that furnace pull. Down below, I've added our KPIs so we can keep track of things like late jobs, etc. But I'm really going to focus on the setup time. Now, if you had your typical scheduler built into your ERP system, you would probably have access to something like a typical forward schedule by due date. So if we do that, what we can see is that the glass colors are all over the place because the due dates are all over the place. And basically, Preactor has mimicked a standard schedule and put jobs where they should go based on due date. And obviously, that violates all kinds of rules that we have set up for the glassware. So what we'll do is we'll pull those off the board, and this time we will go ahead and run an APS rule specific for this sequence called the Glassware Rule. And if you remember from our previous introductory slides, that is keeping glass color the same, keeping shapes the same, keeping product families the same as much as possible to minimize that setup time that we're going to look for. So the first time we ran it, we had like 890 hours of setup time. So let's see what the APS Glassware Rule can do. And I put animation on so you can see it's moving forwards. Sometimes there'll be a little hole and it will find a small job to fit in there. We've come towards the end of that. Now we're going to do the glass colors. Okay, so first of all, visually, you can see that the clear glass is all bunched up together, and the colored glass is on one line only, which was one of our requirements. We take a look at furnace pull. We can see even here in the data, we've actually calculated what those furnace pull numbers are. If we take a look at our plot information, we can see that maximum furnace pull of, for example, furnace A, as of 60, whatever those numbers are, we never violate that. So we're always bumming up against that top red line. We're never exceeding it. If I actually drag a line across, you can see which orders are being pulled from furnace A. And the same thing with B and C. I'll bother to do those. Looking at the schedule, you'd say, well, why is there a gap here? Why did Preactor leave a gap here? Why couldn't it have just snugged that job up? So we'll actually do it and see why Preactor didn't put it there. Is because by putting it there, we would have violated the pull from furnace B. And if I look at the plot, which I should have done earlier, you'd see it red of violating that unit. So I'm going to undo that, put it back where it was. Also, if we take a look at our setup KPI, we're down to 643 hours. So by intelligently scheduling and applying the real-world constraints of our glassware model, we've actually knocked our setup time by about 30%. Plus, we're following all the rules that are built in for the actual production environment. So that's just a simple example of how we can take rules based on the customer or the industry and apply them to an APS Opcenter sequencer model.